So we finished that coherent and coherent sources.
What?
We did one coherent and incoherent sources.
Okay, current and incurrent. Okay, just a minute. Let all of them come, then we will start.
Okay, sir.
What about the questions? Wait a minute.
Okay, sir.
Let's start, Nafisha.
Sir, did you say something?
Yeah, let's start.
Okay.
What about the question?
Sir, I only wrote the two plate monochromatic waves propagating in the same direction with that
Okay,
one.
and that would means you just did one question with me. That's it.
No, sir, we did two, but then I didn't write the other one
All
because
right.
my net was
I don't know. You left in between last time.
yeah, because my net, like I said.
Okay, fine. Look, let me tell you a formula. The relation between phase difference and power difference. 2 pi p power difference over lambda. This is the relation you have to note down in your notebook. Fast.
Yes, sir, done.
Done. Just a minute. Just wait a minute. Fawaz, isn't it?
Yes, yes, sir.
Last time, did you come last time?
Sir, I think wrong class.
Sorry.
Sir, I think wrong class. Like, my meeting was with Talha sir for physics.
Did you come last time? Last
No,
time?
no, sir.
Okay, this is your first class with me.
Yeah, yes, sir.
Okay. So this is the formula that we have to. Do you have any idea about wave optics?
Yeah, yes, yes, sir.
Okay. Okay, just note down this formula, then definitely I'll let you know how to do a question. Note down. This is a phase difference. This is part difference. Fawaz, I hope you might have an idea about it, how to do wave optics. Means little bit.
Yeah,
Do you
yes, sir. I know the
do you know the conditions for constructive interference, destructive interference?
like interference of light. Something I have the idea.
You haven't means do you have idea of wave optics?
Yeah, yes, yes.
Okay, fine. Just try. Just sorry, write down in your notebook first.
Yes, sir, done, sir.
Okay, fine. Now wrote down. Note down a question. In YDSC experiment. Okay, hold a minute. Sorry. Okay. Actually, this question has already come in CBSE in board exam. So note down, I'll let you know how to do these kind of stuff. So in YDSC experiment, the intensity of a light at a point on the screen, note down fast. In YDSC experiment, the intensity at a point on a screen where the path difference is lambda is k units. Full stop. Find the intensity at a point where the path difference is, first is lambda over 4, second is lambda over 3. Written?
Sir, can you repeat?
Yes.
In YDSC experiment, the intensity of a light at a point on the screen where the path difference is lambda is k units.
Sir, of a light?
Of light at a point
Yes, sir.
on the screen where the path difference is lambda is k units.
Yes, sir.
Full stop. Find the intensity at a point.
Yes.
Find the intensity at a point where the path difference is lambda over 4. The first part. And the second is we have to calculate the intensity where the path difference is lambda over 3. So I'll teach you how to do this kind of question. Written.
Yes, sir.
To calculate
Yes,
the
sir.
intensity, you have to remember this formula 4 I naught cos square 5 over 2. Just I equals to 4 I naught cos square 5 by 2. All right. Done.
Yes, done, sir.
Okay. Look. The initial conditions. What is given in the question, when the path difference is lambda, the intensity is k units. All right. When the path difference is lambda, the intensity is k units. So what we have to do it, the formula that I told you, that phi equals to 2 pi p over lambda. Now, when the path difference is lambda, then phase difference will come out 2 pi. This is phase difference basically. All right. All right, Nafisa, Fawaz.
Sir, can you
Sir, can you
explain
say it
again?
again?
All right, this is the formula to calculate the intensity. Note down in your notebook.
And yes, sir.
All
Got
right.
it.
Now
I
the
found
initial
it.
condition, the initial condition is given that when the path difference is lambda, the intensity is k units. All right. It is given in the
Okay.
question. Okay, fine. So first of all, we have to calculate the value of I naught. We have to calculate the value of I naught. Now, what is given? Basically, intensity is given. Now, intensity is given and path difference is given. But first of all, we have to calculate the value of I naught. What we have to do first, we have to calculate the value of phase difference by putting the value of path difference, that is lambda, given in the question. If you substitute it, then you will get phi equals to 2 pi. All right.
Yes, sir. Okay.
Now substitute the value of phi 2 pi into this formula. Further, just a minute now. So what is k 4 I naught cos square 2 pi over 2 will cancel out. K 4 I naught. What is cos phi? What is cos phi, Fawaz? Fawaz, what is cos phi? Nafisa, what is cos phi? Cos phi is -1. All right.
Minus. Okay.
I naught equals to K over 4. All right. Now, finally, you got the value of I naught. All right. Fine. Now, now we have to calculate the intensity where the part difference is lambda over 4. Okay.
Yes, sir. Okay.
Now, substitute the value of I naught, that is K over 4. Now, further, again, we have to calculate the value of phi. Now, what is part difference is given? Part difference is lambda over 4, I think. Lambda will cancel out 2, 2. Then the phase difference is pi over 2. Now, substitute it. Cos square pi by 2 and pi by 4. Now, Nafisa, what is cos pi by 4? Nafisa, what is cos pi by 4? Nafisa, what is cos pi by 4?
Minus 1/4.
No, 1 over root 2. All right. So intensity will
Okay.
come out K over 2. This is the answer. Okay. Do you have problem? If my speed is so fast, then you can stop me in between. Shall I repeat?
Yes, sir. Can you repeat?
Okay, fine. Initial conditions are given. Sorry, initial condition is given when the part difference is P. When the part difference is lambda, the intensity is K units. So what did I do first? I substitute the value of part difference into this formula, as I told you short while ago. Now substitute the value of pi. Pi is 2 pi. Now substitute the value of pi, that is phase difference, into this formula. You'll get the value of I naught. Okay. That I is given K units. I naught we have to calculate it. Further cos square 2 pi 2 2 will cancel out cos square pi, and pi is minus 1. So 1 square. So I naught equals to K over 4. All right.
Okay, sir.
Now further what we have to do it. Now finally we got the value of I naught. Again, the condition is asking when the part difference is K over 4 lambda. All right. The part
Okay.
difference K over when the part difference is lambda over 4, then what is the intensity? So intensity, the formula, we have to use the same formula. I equals to 4 I naught cos square pi over 2. Now again we have to calculate the value of phase difference. So 2 pi lambda over 4, lambda will cancel out. 2, this is 2, it would be 2 if you cancel. So the part difference will come out pi over 2. All right. All right, Navisha.
Okay, sir.
Now substitute the value of pi into this formula. You'll get the answer. All right.
Okay, sir.
Now do the second part and just note down in your notebook. Then we will start with YDSC. All right.
Okay.
Fast.
Sir, can you explain? I didn't get the answer.
Okay, sure. Look, you have to do in the similar way.
Okay.
First of all, so what was the value of I naught? I naught was k over 4. All right.
Okay, sir. Yeah.
Now, again, we have to calculate the value of phase difference. So the formula was lambda. What is part difference given, by the way, Nafisha, in the question? What is path difference is given?
Sir, lambda by 3, lambda by 4, and
Lambda,
lambda by 2.
lambda by 3. All right. Now
Yes, sir.
you have to use the same formula again. What is what I naught? Substitute the value. This is 6. What is this is k over 4 cos square. What is cos square pi by 3? 1 over 2. All right.
Yes, sir.
K over 4 is the answer. Now note down. Actually, this question has already come in board exams. And you'll get the same kind of question in NCRT. All right, just complete your NCRT.
Okay, sir. Yes, sir. Okay.
Yeah, Nafisha. Now, what were you saying?
I finished noting it down.
Did you get?
Yes, sir.
Okay, fine. So shall I give you one more question? Will you be able to do it yourself now? And if you get any doubt, then you can ask me now. All right.
Okay, I'll
Then
try.
then you'll be confident in that topic. All right. Fine. But because this is YDSC, and what I personally feel, YDSC is the most important topic of this chapter, and diffraction also. From hygienes, you'll get hardly 2 marks question. But from YDS, you'll get at least 3 to 4 marks question. And definitely you'll get these kind of numerical because the derivation is already added,
Yes, sir.
omitted from the syllabus. Fine, derivation is already omitted from the syllabus. Now write down the question. Find the ratio. This question has already come. Find the ratio of the intensities. Find the ratio of the intensities of 2 points P and Q Find the ratio of intensities of 2 points P and Q on a screen Find the ratio of the intensities. Find the ratio of intensities of 2 points P and Q on a screen in YDSC experiment when waves from the sources S1 and S2 have phase difference. Very easy question. Very, very easy. When the waves from the sources S1 and S2 have phase difference of 0 degree. It means what is phase difference? Phase difference 0 degree is given. Now let me know the answer first. We have to calculate the ratio, by the way.
Okay, sir.
First. Sorry, and the second, when the path difference is 0 degree and when the path difference is pi by 2. And if you are not able to do it, then you can ask me, all right? Nafisa, it's not a big issue, all right?
Okay.
But the question is completely similar. You have to use the same formula, intensity formula. The phase difference is already given. In this question, you are not supposed to calculate the phase difference because the phase difference is directly given in the question, all right?
Okay, okay, sir.
There is no need to calculate anything else.
Okay.
Navisha done, but still you're getting problem. Nafisa, do you have problem?
Sir, 2 by 1.
All right, great, done. Finally, you got the answer. Now, concept is completely crystal clear. Or still, you have a doubt?
Yes.
Now, the formula you are able to apply it. If you get this kind of stuff in your exam, now you are able to do it.
Yes, sir.
Okay, fine. Wait a minute. Let me draw a figure.
Okay.
Then Navisha, draw this diagram. Then,
Okay, sir, drawing.
then I'll explain to you.
Yes, sir, done.
Fine. Now what happened? This is YDSC experiment. This is the source. These are the slits. This is S1 and S2. This is the this is the source. These are the slits. The distance between the slits is small d, and this is the screen. This is screen. Fine. So this is the d is the distance. Capital D is the distance from the slits, and small d is the separation between this. That would be P is the point where this is a central bright. Fine. This is a central bright. Do you know last time I told you YDSC? YDSC, what happens? There are two types of interference, constructive and destructive interference. Where the constructive interference happens, you'll get a bright spot. Fine. And where you get,
Yes, sir.
when destructive interference happens, you get dark spot. Fine. So this is a central bright. It means you get bright spot. Then the next bright spot at point P, you'll get after this. All right, Nafisha.
Yes, sir.
Now, what is path difference? What do you mean path difference? For example, let it be two ways. One is going from S1 and another one is going from S2. All right.
Yes, sir. Okay.
The extra path traveled by the wave from S2 is known as path difference. Now, this is known as path difference. This is path difference. All right.
Okay.
Now, the derivation is not in the course. No, P is the path difference. So the formula is P XD over capital D. Note down, this is the path difference. First.
Yes, sir, done.
Now the positions of bright fringes. Shall I rub it?
Yes, sir, you can rub it.
Now, first is position of bright fringes. Remember this formula, xn equals to n d lambda over d. Right. For nth fringe. This is for nth fringe. For example, if we have to calculate the first bright fringe from the central bright, then you have to substitute n equals to 1. All right. Where
Yes, sir.
n equals to 1, 2, 3, and so on. Then next, position of dark fringes for nth fringe. Xn equals to nth dark fringe. Nth dark, and for nth
Sir, what is that after 2n minus 1?
d lambda over 2d.
Okay, sir.
Once you done, then let me know.
Yes, sir, done.
Now, note down fringe width. Fringe width. Then I'll explain you what is fringe width. So as I told you, in YDSC, what happens? You'll get alternate dark and bright fringes. For example, means at the center, you'll get bright fringe, then dark fringe, then bright fringe, then dark fringe. And this pattern will repeat again and again. Now what happens? What is fringe width? So let it be 2. This is a central bright, then again you will get bright. But in between these 2 fringes, you'll get a dark fringe. All right.
Okay, sir.
Let it be, this is a dark fringe. Now, fringe width means the width of this dark fringe is known as the width of this is known as fringe width. But look, if we have to calculate the fringe width of dark fringe, it means we have to take 2 consecutive, the separation between the 2 consecutive bright fringes. This is bright, this is what we are doing. We are taking the separation between the 2 consecutive bright fringes, and you'll get the fringe width of dark. All right.
Okay, sir.
But if we have to calculate the fringe width, you have to do the same thing. It means if we calculate the separation between the 2 dark fringes, this is dark, then you'll get the fringe width of bright. Now, note down the definition. I'm dictating. It is the separation between successive bright fringe or dark fringe. Note down, it is a separation between 2 successive bright or dark fringes.
Yes, sir.
Now note down width of a dark fringe. When we calculate the width of a dark fringe, it means we have to take the separation between, Nafisa,
Separation between 2 successive bright or dark fringe. Bright and dark fringe.
When we talk about width of dark fringe, it means we have to take the separation between 2 consecutive bright fringes. All right.
Okay, okay.
Note down. Note down. Now this is the width of dark fringe. Likewise, you'll calculate the same thing. Now note down, then I'll tell you the width of bright fringe. Look, what did I do? This is the formula I just calculated. The position of the bright fringe. Do you remember? We just discussed.
Yes, sir.
Okay. What did I do? I just subtract n minus 1 fringe from nth fringe. All right. And you'll get the width of the dark fringe.
Yes, sir. Yeah.
Once you're done, let me know.
Yes, sir. Done.
Nafisa, further. Just a minute.
Okay.
Now width of right fringe. We have to take separation between two consecutive. Two consecutive. Nafisa?
Dark fringes.
Yeah. Now, what is the form? What was the formula for position of nth dark fringe? I think it was 2n minus 1
2n minus 1, yeah.
over 2d minus nth minus 1. All right.
Okay, yes, sir.
Now, if you'll get the same thing. So both bright and dark fringes are of equal width or same width. And this is hence, so this is fringe width d lambda over d. Now, note down.
Sir, that's P equals D. Like
Which
the
one?
hands one. The one in the box.
Beta,
That one.
beta
Oh, okay.
beta equals to d lambda over d.
Yes, sir, done.
Let's do it further. Make some notes. Beta is independent of n. It means the order of the fringe. All right.
Do I have to write that down?
Yeah.
Okay. Sir, can you say it again?
Beta is independent of n, the order of fringe width. It means the width of second fringe, third fringe, right fringe, or dark fringe, or will be of equal length. All right.
Okay, sir.
Done.
Beta is independent of N.
N,
And
the order of the fringe width.
okay, sir.
Okay. Next, angular. Angular width of a fringe. Note down first.
Yes, sir, done.
Next, look, if the YDSC, this apparatus, is immersed in a liquid of refractive index mu, then the fringe width will become beta over mu. All right. If the apparatus is immersed in a liquid of refractive index mu, then the fringe width will change. All right.
Okay. Sir, can you repeat the sentence again? If YDSE is immersed in.
If YDSC apparatus
Okay.
is immersed in a liquid of refractive index mu,
Yes, sir, done.
then the fringe width reduces to this much. Beta dash equals to mu over mu. Beta dash equals to beta over mu.
Yes.
Now we will discuss the question. Note down. In YDSC experiment, the two parallel slits are made 1 millimeter apart. Nafisa, done?
Yes, sir.
In YDSC, in Young's double slit experiment, the two parallel slits are made of 1 millimeter apart and a screen is placed 1 meter away. What is the fringe separation? What is the fringe separation when the blue light of wavelength 500 nanometer? What is the fringe separation when the blue light of wavelength 500 nanometer is used?
Sir, two parallel slits are made 1 millimeter apart or 2 millimeters apart.
1 millimeter.
Okay.
And a screen is placed 1 meter away.
Yeah, okay, sir.
What is the fringe separation when the blue light of wavelength 500 nanometer is used? Do you know how to switch nanometers into meter?
No.
Okay, fine. 1 nanometer equals to 10 raised to the power minus 9 meters and 1 millimeter equals to 10 raised to the power minus 3 millimeter. The beta formula, you have to use it to calculate the fringe width. Beta equals to lambda capital D over small d. Everything is mentioned in the question. You have to substitute the value. This question is straightforward. Fine. And I hope you will be able to do it. But if you are not able to get it, then you can ask me.
Okay, sir.
Do it. I just come in a minute. All right.
Okay, sir.
Nafisa, am I audible?
Yes, sir.
Okay. Do you have problem with my handwriting? If you're not able to get it, please let me know. My handwriting is not good. All right.
Okay, sir.
If you don't get anything, please let me know. All right.
Okay, sir.
This is beta dash equals to beta over mu. All right.
Yeah, okay. Okay, sir.
Nafisa, done? Or still you have a problem?
Sir, the answer is 5 times 10 by 4.
10 raised to power minus 4.
Yeah, not by, sorry, raised to the power. Oh, minus 4, okay. I wrote 4.
Okay, fine. No, it is an NCERT question. This one. Okay, now do the next one. Now, laser light of wavelength 630 nanometer. Are you writing?
Yes.
Okay. Laser light of wavelength 630 nanometer is incident on a pair of slits produces an interference pattern in which bright fringes are separated by 8.1 mm in which bright fringes are separated by 8.1 mm, that is millimeter. A second light
Sir, 8.1 mm and then?
a second light produces an interference pattern in which fringes are separated by 7.2 mm. Today I'll complete YDSC, and in the next class I'll complete diffraction. Then this
Okay.
chapter will be completed. Fine.
Okay, sir.
I'll make you do sufficient practice.
Okay.
And look, Nafisa, whatever I teach you today, just practice at home. All right. This
Okay,
chapter
sir.
this chapter is very, very easy.
Okay.
0.8 mm. A second light produces an interference pattern in which fringes are separated by 7.2 mm. Calculate the wavelength of the second light. Calculate the wavelength
Sir, interference patterns in which fringes are?
separated by 7.2 mm.
Yes, sir.
Calculate the wavelength of the second light. Fast. Fast. Nafisa, are you able? Are you getting this question how to do it?
Yes, sir.
Okay, fine. Look, we have to calculate basically the lambda 2. So you have to use the formula beta equals to d lambda over small d.
Yes, sir, I'm doing that.
Okay, if you don't get it, then you can ask me, all right?
Okay, sir. Sir, 26.6 nanometer.
Just a minute. 560 nanometers.
Wait, uh, sir, the question like the laser light of wavelength 30 nanometer.
630 nanometer.
Oh, I wrote there. Wait, sir, the answer is 560 nanometer.
Good. Finally, you are getting how to do this kind of stuff.
Yeah,
Very good, Nafisa. Whatever I'm teaching you, will you be able?
yeah, yes, sir.
Next question. In two-slit experiment with monochromatic light, fringes are obtained on a screen. In a two-slit experiment with monochromatic light, fringes are obtained on a screen placed at some distance, capital D, from the slits. In two-slit experiment with monochromatic light, fringes are obtained on a screen placed at some distance, capital D, from the slits. Full stop. If the screen is moved 5 into 10 to 1 minus 2 meter towards the slits,
If the screen is moved, and then
is moved 5 into 10 to 1 minus 2 meter towards the slits, comma, the change in fringe width is 3 into 10 to the power minus 5 meter.
The change in fringe width is
3 into 10 to the power minus 5 meter. Full stop.
yes, sir.
If the distance between the slits is 10 to the power minus 3 meter.
If the distance is
If the distance between the slits is 10 to the power minus 3 meter.
yes, sir.
Now, if the distance between the slits is 10 to the power minus 3 meter, calculate the wavelength of the light used.
Calculate the wavelength of
The light used.
okay.
Nafisa, are you getting how to do this kind of question?
Yes.
Shall I do? For you,
Yes, sir. Okay.
okay. Now in the two select,
Sir,
yeah,
so far I got 3/5 multiplied by 10 minus 6. Sorry, multiplied by 10 to the power of -6.
3 into 10 to the power minus 5 into 10 to the power minus 3 over 5 into 10 to the power minus 2. You got the same thing, isn't it?
What? Yeah, 3/5 multiplied by 10 raised to the power of minus
You're
6.
getting this thing.
Yes. Yes. No. Yeah. That was before. And then after that, now I'm getting 3/5 multiplied by 10 raised to the power of -6.
The answer into 10 to the power minus 6, 7. Wait, this is the answer.
Okay.
Done. Done. Nafisa?
Yes, sir.
Okay. Next question. In young double slit experiment, red light, note down. In young double slit experiment, written
Yes, sir.
in young double slit experiment, the red light of wavelength 6000 angstrom
In young double slit experiment, light of wavelength.
6000 angstrom is used. And
Yes, sir.
nth bright fringe is obtained at point P. And nth bright fringe is obtained at point P on the screen. Full stop. Keeping the same setting, the source is replaced by the green light. Done.
Yes, sir.
Of light of 5000 angstrom. And now n plus 1th bright fringe is obtained at point P. Now calculate the value of n.
Sir, 5,000 Armstrong, and then now and it.
Now n plus 1th bright fringe, n plus 1.
Yes, sir. Okay.
And now if the two fluids, fringe is obtained at point P, full stop, calculate the value of small m. Done.
No, sir. I'm still doing.
If you don't get it, please let me know. You have to use nth fringe, bright fringe formula, all right?
Okay.
After this, we will do just one more question. Then we will do it. We will start diffraction in the next class, all right?
Okay.
Okay, too fast.
Sir, can you do it? I'm.
You're not getting how to do it.
Yeah.
Okay. Just a minute. What is given? When x equals to n d lambda over d, so n d wavelength is 6,000 strong. We have to change into meters. 1 Armstrong equals to 10 to the minus 10 meter. All right.
Yeah, sir. Okay.
Over d. All right.
Yes, sir.
Now further, nth plus 1 fringe, lambda 2, lambda 1. So n plus 1 d into 5,000 into 10 to the minus 10 over d. All right. Now both are equal. Just equate them. You will get the value of n. All right, Nafisha.
Yes, sir.
Will you be able to do it yourself?
Okay, sir. I'll try.
Okay. Done. Nafisa. Now, finally, did you get the
Yes, sir.
complete concept of YDSC?
Yes, sir.
Now, do you have any doubt regarding any topic? Last one and this one, any topic, hygienes, wavefront, coherent, incoherent, intensity formula, diffraction, constructive, destructive, anything?
No, sir. Just this question. I don't understand how you can.
How did I do it?
Because
How did I do it?
yeah.
Okay, everything is precisely mentioned in the question. When the wavelength is 6,000 Armstrong,
Yeah.
the
Okay.
the distance from the central bright fringe is this. All right.
Yeah.
At this distance, we are getting nth bright fringe.
Okay.
But when we replaced our light having wavelength lambda 2, that it means we are getting at the same distance, but the fringe becomes
Yeah.
n+1.
Okay.
So the distance from the central bright the distance from the central bright is same.
Okay.
Fine. I just equate them. Means if you equate them, do you have problem in solving? So I'll solve for you.
Yeah. It's the yeah.
Okay,
How
okay,
do you equate this? How did you get 5?
okay. Now n d lambda 1 over d, then n+1 d lambda 2 over d. D will cancel out. So n lambda 1 equals to n+1 lambda 2. All right.
Yes, sir.
What is lambda 1? 6,000 Armstrong.
6,000 Armstrong. Yeah.
N+1. What is this? Is 5,000 Armstrong. Three zeros will cancel out. So n6 equals to 5n plus 5. This is 6n.
Okay, sir.
So n will come out 5. All right. If you move this side, so 6n minus 5n equals to n.
Yes, sir. Okay, understood.
Do you have problem?
No, sir.
Great.